This video segment continues to examine the direct effects of rising atmospheric carbon dioxide concentrations on plants. It focuses on the influence of carbon dioxide enrichment on nutrients, especially nitrogen. Its major points are: number one, most plants acquire their mineral nitrogen through root absorption of inorganic nitrogen ions from the soil solution. Number two, elevated carbon dioxide concentrations inhibit nitrate assimilation into protein. Number three, herbivore populations decline at elevated carbon dioxide concentrations. With rising atmospheric carbon dioxide concentrations, the availability of energy and water resources increase and stimulate plant growth. The availability of nutrient resources may not keep pace. In particular, nitrogen resources tend to lag behind. Consider the effects of atmospheric carbon dioxide concentrations on the major sources and sinks of mineral nitrogen, ammonium and nitrate in soils. Major sources of mineral nitrogen in soils are biological nitrogen fixation and nitrogen mineralization, the microbial breakdown of soil organic matter into mineral nitrogen. These processes are generally independent of atmospheric carbon dioxide concentrations, but nitrogen fixation may decrease under carbon dioxide enrichment if soils do not receive additional nutrients. Plants under carbon dioxide enrichment initially grow faster and release more carbohydrates to soils. In response to the input of additional energy, soil microorganisms become more active, respiring on average 18% faster than under ambient atmospheres. As soil microorganisms become more active, they remove more nutrients from the soil. Iron and molybdenum, both of which are required for nitrogen fixation, may become scarce and nitrogen fixation may decline. A major sink for soil mineral nitrogen is nitrogen immobilization, the process through which soil microorganisms incorporate mineral nitrogen and thereby diminish its availability to other organisms. As soil microorganisms become more active under carbon dioxide enrichment, nitrogen immobilization increases an average of 22%. Because inputs of mineral nitrogen to soils stagnate under carbon dioxide enrichment, while microbial extraction of nitrogen from soil increases, nitrogen availability to plants decreases under carbon dioxide enrichment. The availability of soil mineral nitrogen therefore determines plants' responses to elevated carbon dioxide concentrations more than any other environmental factor. Plants receiving high amounts of nitrogen fertilizer respond much more vigorously to carbon dioxide enrichment than those exposed to low amounts. Moreover, stimulation by nitrogen fertilization becomes more pronounced with time of exposure to elevated carbon dioxide concentrations.